Good morning, dear students. Today, in this lecture, we are going to see about matrices and types of matrices. First, we are going to see about definition of a matrix. Matrix is an arrangement of elements or numbers which is in rows and columns. The numbers are enclosed by the parentheses or brackets or double bars. We have a following examples where the numbers are allocated or enclosed by the parentheses and in the closed brackets and in double bars. Next, we're going to see about the order of a matrix. If any matrix is having number of rows m and the number of columns are n, then the order of the given matrix is denoted by m cross n. We have an example which the matrix have two rows and two columns. So the order of the matrix is 2 cross 2. The general form of the matrix is given in the following parenthesis, that is closed bracket. Here we have m rows and n columns. So the values of the matrix start as from a11 to a1n and it is continuous up to m rows. So am1 to amn. So the above matrix can be written as capital A is equals to aij, which is of order m cross n, since the matrix have m rows and n columns. Here aij is the element at ith row and jth column and it is referred as I comma jth element. Now we are going to see about the types of the matrices. We have different types according to the number of rows and columns of the matrices. First, we are going to see about square matrix. If the number of rows and number of columns are equal in a given matrix, then the matrix is said to be a square matrix. That is, if the number of rows that we know it is be m and the number of columns is equal to n, then both are n means then the matrix is called to be a square matrix of order n. We can have an example here. Here we can see the matrix have two rows and two columns. So this is a square matrix of order 2. Next we are going to see about the row matrix and the column matrix. If there is only one row in a given matrix, then it is called as the row matrix or row vector. The same way, if there is only one column in a matrix, then it is called as column matrix or column vector. We can see the simple examples given in the following. Next, we are going to see about the identity matrix. A square matrix whose diagonal elements are 1 and the non-diagonal elements are 0, then it is called to be a unit matrix or identity matrix. We already know about what is a diagonal matrix. Diagonal matrix means the leading elements of the matrix diagonal values should be any value other than the elements, diagonal elements must be 0, that is called as diagonal matrix. If the diagonal elements are 1, then it is said to be the identity matrix. So we can have the example of identity matrix of order 3 cross 3. You can see that the diagonal elements of this matrix have only the number 1 in the diagonal and other values are 0. Next we have symmetric and non-symmetric matrix. A square matrix such that we can denote the matrix as Aij. If it is equals to Aji for all I and j, then the matrix is called a symmetric matrix. What is they saying here? See, if you have a matrix, then if you take a transpose of the matrix, then if both are equal, that is, the matrix and the transpose of the matrix are equal, then it is called as symmetric. What does mean by transpose? Transpose means, that is, you're going to rearrange the matrix rows and columns vice versa. That is, the rows values as column and column values are rows, then you can get a transpose of the given matrix. Now, if both transpose of the matrix and the given matrix have same values, then it is called to be a symmetric matrix. If it is not a square matrix such that Aij is equals to negative of Aj, then we can say that this matrix is a non-symmetric matrix. Next we have about orthogonal matrix. A square matrix A is said to be orthogonal if A transpose is equals to A transpose A is equal to the identity matrix. If we can able to get that, the A transpose multiplied with A matrix or the A matrix multiplied with A transpose should be equal to identity matrix, then it is said to be a orthogonal matrix. Next, we are going to see about non-singular matrix. A square matrix is said to be non-singular matrix if the determinant should be not equal to 0. Okay, then here a square matrix is said to be singular matrix if determinant is equal to 0. Thank you. We can see the next topics in the next video.